In the previous video, we were able to find the six trigonometric functions of angles between 0 and 2 pi. But what happens if the angle isn't between 0 and 2 pi? How do we find the six trigonometric functions of that? Well, what we're going to do is we're going to find coterminal angles that fall within the domain from 0 to 2 pi. And then what we can do is we can just use the unit circle to find those definitions. So we have this theta, which is equal to negative 4 pi thirds. And what I might recommend is that first let's convert it into degrees, just because a lot of students are a lot better with working degrees than radians. Although if you want to keep it in radians, that's fine. So what I'm going to do is I'm going to take negative 4 pi over 3, and I'm going to multiply by 180 degrees over pi. And you probably remember the trick where we would just go through and put that in our calculator to see how many degrees we have. All right, so we have negative 4 thirds, and we're going to multiply that by 180. All right, and that gives us negative 240 degrees. All right, so this is going to be equal to negative 240 degrees. Now, clearly that's not on the unit circle, because remember, our unit circle only goes from 0 to 360, okay? And in fact, remember, 0 and 360 are coterminal, okay? So really, I think it goes to 330. But what we're going to do is we're going to get a coterminal angle. And remember, to get a coterminal angle, what we're going to do is we're going to add or subtract 360, okay? So let's add 360 to this. And if we add 360 to negative 240, that's going to be 120 degrees. And so what we're saying is that our theta is coterminal to 120 degrees. So realistically, if I wanted to find the sine of negative 4 pi thirds, that would be the same thing as the sine of 120 degrees. And if I wanted to find the cosine of negative 4 pi thirds, that would be the same thing as the cosine of 120 degrees, etc. We could just go right down the line. And so the tangent of negative 4 pi thirds is the same thing as the cotangent of 100, or I'm sorry, the tangent, excuse me, not the cotangent, that wouldn't make any sense for most values. And that would be the tangent of 120 degrees, etc. Okay, so let's find those three first. Remember, the sine is the y, the cosine is the x, and the tangent is the y over x relationship. So we're going to go up to our unit circle. We're going to look at 120 degrees, and we see that the x coordinate is going to be negative 1/2, and the y coordinate is √3 over 2. So we hold on to those, and right away we can say that the sine of negative 4 pi thirds, which is the same as 120, is going to be √3 over 2. Right? And then the cosine is going to be negative 1/2. Okay, and again, what I did was I just went all the way up to the unit circle. This is the sine, this is the cosine function at 120. All right. The ratio of y over x is going to be the tangent function, and so that's going to be √3 over 2 divided by negative 1/2. If we were to multiply by the reciprocal to clean this up, √3 over 2 times negative 2 over 1, or that just becomes negative square root of 3. And now what we're going to do is we're just going to take the reciprocals of each of these three functions to be able to find the cosecant, secant, and cotangent functions. Okay, so for our cosecant of negative 4 pi over 3, now remember that's going to be 1 over y. That's going to be the reciprocal of the sine function. So that's going to be 2 over the square root of 3. And let me write that a little more vertically, because we are going to have to clean that up by multiplying by the conjugate, or I'm sorry, to be able to clean that up, we're just going to multiply by √3 over √3 to rationalize it. All right. And the numerator just becomes 2 roots of 3. The denominator just becomes 3. Okay, so this just becomes 2 roots of 3 over 3. All right, so that's going to be our cosecant function. The secant function is actually really easy, because that's going to be 1 over x. And remember, our x coordinate was negative 1/2. So that's 1 over negative 1/2, which is going to be 1 times negative 2 over 1 by multiplying by the reciprocal, or that's just negative 2. Finally, the cotangent at negative 4 pi thirds is going to be the same thing as x over y, which is the reciprocal of our tangent function, which we found to be negative root 3. So that's going to be 1 over negative roots of 3. And what we're again going to do is we're going to rationalize this. Okay, so let me write it like negative 1 over the square root of 3. When we rationalize it, we just multiply by root 3 over root 3. And so this just becomes negative root 3 over 3. All right, so that becomes negative 1 times root 3 is root 3. Root 3 times root 3 is 3. All right, so those are our 6 trig functions. Again, all we did was we just went to the unit circle and we looked these up for the x and the y coordinates, and we also got a coterminal angle. A second example of this is when theta equals 17 pi 6. So once again, we're going to do the exact same thing, and we're going to convert this into a degree measure. So we take our 17 pi over 6, we multiply it by 180 over pi. Pi's cancel out. And in our calculators, we just do 17 times 180 divided by 6. And that gives us 510 degrees. Now, we clearly know that 510 is not in the domain. Okay, remember our domain for our unit circle is between 0 and 360. Okay, so what we're going to have to do is we're going to have to find a coterminal angle that falls in that domain. To do so, we subtract 360. And if we do that, that's going to be, I believe, we subtract that out, 150 degrees. So we know that 150 degrees is going to be coterminal to 17 pi 6. So realistically, what we're going to say is that the sine of 17 pi over 6 is going to be equal to the sine of 150 degrees. And the cosine at 17 pi over 6 is going to be equal to the cosine of 150 degrees. And then shockingly, the tangent at 17 pi 6 is going to be equal to the tangent at 150 degrees. All right, so let's go into our unit circle. Let's find those relationships of x and y at 150 degrees. And if we go up here to our unit circle, we have 150 degrees is right here. We see that the x coordinate is going to be negative root 3 over 2. We see that the y coordinate is going to be a half. Okay, so x equals negative root 3 over 2. Y is equal to a half. And then we substitute back in. Okay, of course, by now we should have these memorized. Okay, remember the sine is the y, the cos is the x, the tangent is y over x. All right, so the y coordinate at 150 degrees was 1/2. The cosine was negative root 3 over 2. Okay, and again, just go back up, make sure that you got these down. Okay, so the y is a half, x is negative root 3 over 2. All right, so it never hurts to check. And then finally, for the tangent, or that's y over x, so that's going to be 1/2 over negative root 3 over 2. We're going to clean that up by multiplying by the reciprocal, so that's 1/2 times negative 2 over root 3. Those are going to cancel out. That's going to be negative 1 over root 3. Or if we were to rationalize that, so let me put that in a more vertical fashion. I always do that for some reason. All right. We are going to multiply by root 3 over root 3. We've seen this a couple times, right? And if we multiply by root 3 over root 3, this should be root 3 over 3, okay? Or negative in this case, so negative root 3, and then root 3 times root 3 is 3, right? So that's our tangent function. Okay? Now, we can find the secant, cosecant, as well as the cotangent function by finding the reciprocals. Recall that the cosecant of 17 pi over 6 is going to be 1 over y. Well, 1 over y is going to be 1 over 1/2, which is the same thing as 1 times 2 over 1, which is 2. All right, so that one's easy. The secant function, a little bit uglier, but not too bad. That's going of 17 pi over 6. That's 1 over x, which is going to be 1 over negative root 3 over 2, or the reciprocal of this, which is going to be negative 2 over root 3. And then we can rationalize that just like we've rationalized a whole bunch of stuff. Okay, so that's going to be root 3 over root 3. And so that should be negative 2 roots of 3 over 3 when we multiply across. Okay, so negative 2 roots of 3 divided by 3. Finally, we're going to rationalize and take the reciprocal of the tangent function to get the cotangent. So the cotangent of 17 pi over 6 is going to be x over y. And that's going to be equal to the reciprocal of this animal. So that's going to be 1 over negative root 3 over 3, which is 1 times negative 3 over root 3, which is just going to be negative 3 over root 3. We're going to rationalize that. So let me write that again. Sorry, sometimes it's tough when I write on the screen. You might have heard me say that a few times. Never gets old, I'm sure. We're going to rationalize by multiplying by root 3 over root 3. And so finally, this just becomes, if we were to simplify it, the opposite of 3 roots of 3 over 3. Those 3's cancel out, and we're left with negative root 3. All right, so that's our trig functions of any angle. All right. I guarantee you on an examination, I'm going to ask you a problem where I ask you to find all 6 trig functions of an angle that's not between 0 and 2 pi or 0 and 360 degrees. All right, so this is an important problem for us. Okay, it's fundamental to the course. So in our last videos in this series, what we're going to be looking at is we're going to be looking at some of those identities that we've already seen. And we're going to kind of build some relationships between sine, cosine, tangent, cosecant, secant, and the cotangent functions. And we're going to find a few more other than just the reciprocal identities. So that'll be in our last set of videos for this series, as well as even and odd with respect to our trigonometric functions.